Running apps in virtual machines means that they're essentially sandboxed in runtime. This means that the apps cannot directly interfere with the operating system and other apps, nor can they directly access the device hardware. Each app is granted a set of permissions at install time and cannot perform operations that require permissions it does not have. More specifically, the Android platform takes advantage of the Linux user-based protection as a means of identifying and isolating application resources. The Android system assigns a unique user ID or UID to each Android app and runs it as that user in a separate process. The kernel enforces security between apps and the system at the process level through standard Linux facilities, such as user and group IDs that are assigned to the apps. By default, apps cannot interact with each other, and apps have limited access to the operating system. If App A tries to do something malicious like reading App B's data or dialing the phone without permission, then the operating system protects against this because App A does not have the appropriate user privileges. This sandbox model is simple, but on the other hand, it is based on decades-old Unix-style user separation of processes and file permissions. An app can announce the permissions that it needs, and user approval is required and install time. The permissions are typically implemented by mapping them to Linux groups that have the necessary read-write access to relevant system resources, such as files and sockets, and therefore they are ultimately enforced by the Linux kernel.